All right, so let's keep going. Here we have 3 more functions. And yes, they are all functions because if you look, they all pass the vertical line test. This one's a little bit curious, but I want you to recognize that this inverse variation graph has what we call asymptotes. And what happens is it snuggles up to the axis, but it doesn't ever cross or approach the axis. Hey, this graph comes from an equation that looks like this. And because x is in the denominator, we can't ever have a value of 0. So what ends up happening when we talk about our domain, we say, okay, everything from negative infinity up to, but not including 0, is going to cover what's happening on this side. And then over here, everything from 0 on up to positive infinity. So notice the way that that works is we don't have 0 included. So it's everything up to 0, hop over it, and then everything continuing on. Guess what? Our range is going to be the same kind of story. Because if I can't ever put 0 in, I'm never getting 0 out. There's no way I'm ever going to have 0 as an output when I look at this equation. And is it a function? Yes. So our domain for our quadratic is a little bit different because anything can go in. This graph continues on in this direction forever and ever and ever. So guess what? It's going to keep getting smaller. It's going to keep getting bigger. So all of these x's forever in both directions are potential inputs. But what do we have for potential outputs? You notice that the range of this function, it goes on forever and ever in a negative direction. So all these negative numbers are possible y values. But guess what? Our function is never going to go above 1, 2, 3, 4. If you want to, you can go ahead and estimate that. We'll go ahead and call that 4.2. And then I think that this graph shifted. Usually we try to keep things as whole numbers. So we can estimate and do our best guess for this one. Is it a function? Yes, of course it is. All right. Our absolute value function is going to have this sharp point here. But that doesn't change what can go in. Every single negative x, every single positive number could possibly be an x value. Our output is only going to exist above this line. So our smallest y value, -1, 2, 3, and again, it's not quite close, so we'll go ahead and call that -3.5. But guess what? This range is going to go on forever and ever and get bigger and bigger and bigger. Is it a function? Yes, it is. All right, let's move on to section 3 and take a look at this graph. This is a cubic function where it has this fun little loop-de-loop. Is it a function? Yes, it is, because it passes my vertical line test. Is it continuous? Yes, it is, because I can trace the whole graph with my pen. Is it 1-to-1? Uh-oh. See how it fails my horizontal line test? So no, it's not 1-to-1. I get this output 3 times. But guess what? Anything can go in to this function and anything's coming out of this function. All right, let's have our conversation about our ant. What's happening as our ant goes from left to right? The ant is climbing up. So from negative infinity all the way up to this x value here. Remember, it's a conversation about x's. From negative infinity all the way up to, but not including -1, that ant is climbing. During this section, our ant is falling. So from -1 all the way up to +1, that ant is walking downhill. Let's talk about what happens once he gets here. He starts climbing uphill again. So here he is walking up the hill. So from -1 or from +1 on up forever, he is increasing. So notice I add to my story as I tell it. My ant is going up, my ant's coming down, and my ant's going back up. Where is my ant constant? That means where is he walking a straight line? So whenever we're talking about it being constant, we're looking for that ant just walking on a straight line. Guess what? There is none. There's no interval where he's constant. All right, our x-intercept is going to be right here, where it crosses my x-axis. So that's an xy ordered pair over 2 and up 0. Where is my y-intercept? That's going to be here, where it crosses my y-axis over 0 down 2. What is my local maximum? So notice there is no absolute maximum because this continues going on forever and ever. But there is a local maximum right here. And that is where the graph, and that's where it changes from being increasing to decreasing. So that's a high point. So my local maximum is going to be an ordered pair, which is going to be over -1 and down 1. My local minimum is going to be this point here where we turned around. And that's again going to be an ordered pair over 1 down 3. As my x approaches positive and negative infinity, we have to look at the end behavior. Where is my graph going? And as my x's get smaller and smaller, guess what? So does my output. As my x's get bigger and bigger, guess what? So does my output. How's it going? If you have questions, make sure you come to office hours and ask.